before I talk about the foot of perpendicular and shortest distance as well as reflection, okay, let's recap something from vectors 1 that is important. When we draw the triangle, okay, so this is a floor, all right? So let's say there is a A, and then there's a B that is going to be here, okay? And then, so this is the floor, and there's a hypotenuse of, let's say, AC, okay? So if we want to find the length of projection of AC onto AB. So remember, it's always hypotenuse onto floor. You need two vectors. You find out what is AC and you find out what is AB first. Two vectors will always form an angle over here. Okay, so now we draw a dotted line here and we know that this is going to be a right angle triangle. So the length of projection is here, this L thingy. Alright, and the formula from vectors 1 would be AC dot the floor head, AB head. Okay, so that would be the length of projection. Okay, and the projection vector, that means if I want to find L as a vector, is going to be equals to AC, there's no modulus in this case, dot AB head, and this will give you a scalar multiple times of the floor, AB head. Okay, so this is the projection vector, these two formulas must know. And if I want to find the perpendicular distance, okay, which is the shortest distance from C to AB, then is the, again, hypotenuse. Now in this case we cross because we are doing sine, AB head. Okay, but this will give me a vector, so I need to find the magnitude of AC cross AB head. So these three things must know how to use. Draw the two vectors, form an angle first. Know who is the hypotenuse and who is the floor. Then you will be able to apply, okay, these three formula, okay, very, very easily. Okay. Now this part of the question asks, if the question wants you to find this thing called N, which is called the foot of the perpendicular, okay, so these are the steps to find what is the coordinate of N. Okay. So for example, in this case, the question will always structure in this way, that there is a point, 1, 2, 3, and then there is a line. Okay, so understand how to draw a line and a point first. Don't anyhow draw. Okay, it doesn't matter how the lines look like. Always make it flat on the floor. Okay, such that you have a point, 1, minus 1, minus 2, as well as a direction. Okay, 1, negative 2, negative 4. Okay, so there is going to be a point P. So let's say I label this as Q. There's going to be a point P that is on top of the line, which is 1, 2, 3. Okay, so how we're going to draw this triangle is crucial. First step, always join the P to Q. Okay, so which means that PQ, right, is going to be your hypotenuse. Yeah, so join the line from P to Q. Then you have PQ or QP doesn't matter. Okay, so PQ, QP doesn't matter in this case, because at the end of the day later we will do a scalar multiple. You are going to get a constant. Okay, now I draw a dotted line down, okay, and then label this as N. Okay, so N is the foot of the perpendicular. Yeah, okay, so now our job is to find N, right? And the most crucial part is that because N lies on the line, right, you must remember N lies on the line, okay, which means that ON is the same as a R, because R is a XYZ. XYZ means any point that lies on the line. So since N lies on this line, we can say that N can take the form of this equation. This is a super important concept that students cannot understand and cannot use to apply. Okay, but if you cannot start it right, then it's very hard to do. Okay, you cannot say that it's not Qn, you know. Qn is just the direction. Okay, On, a point, this point, On will satisfy this equation. Okay, this 1, negative 2, negative 4 is a direction of Qn, but it may not be Qn exactly. So you cannot say that that is equals to Qn. Okay, so On lies on the line, On is equals to this. Okay, so once you have that, now how to start the working proper? So first we say that On, okay, is equals to, combine these two together, 1 plus lambda, minus 1 minus 2 lambda, minus 2 minus 4 lambda. Okay, so that is ON. Okay, this is very crucial, very crucial. So once I have ON already, then you look, how am I going to get ON? Because I can form this right angle triangle, right? PN is perpendicular to the line. Okay, so I know that PN is perpendicular to the line, and when two vectors are perpendicular, I know that PN is perpendicular to L. So this means that PN dot the direction vector of L will always give you equals to 0. Don't need the point, just take the direction vector will do. Okay, but before that we need to find PN. So first step, step 1, you must say that ON is equals to the equation of the line. Step 2, find PN, which is equals to ON minus OP. 1 plus lambda minus 1 minus 2 lambda minus 2 minus 4 lambda. OP 1, 2, 3. Okay, so I'm going to get like lambda minus 3 minus 2 lambda minus 5 minus 4 lambda. So this is equals to Pn. Yeah. So remember, the important concept is this: Pn is perpendicular to the line. So step 3 is Pn dot d must give you equals to 0. So I will have lambda minus 3 minus 2 lambda as well as minus 5 minus 4 lambda. Dot, just take the direction vector will do 1 minus 2 minus 4. It must be equals to 0. Okay, so work out your lambda. Lambda plus 6 plus 4 lambda plus 20 plus 16 lambda equals to 0. So 21 lambda is equals to negative 26. Lambda is equals to negative 26 over 21. Now we found the lambda already. We put it back to where? To ON. So ON equals to, where is ON? ON is here. Okay, put it back to ON. ON is equals to 1 minus 26 over 21 minus 1 minus 2, 26 over 21, and minus 2 minus 4, negative 26 over 21. And that is how you find the coordinate of ON, which is the foot of the perpendicular. Okay, so give me a while, let me work it out. Okay, yeah, after working out, okay, you are going to get this fraction. So ON is the foot of the perpendicular. So this is how usually we find the foot of the perpendicular. So remember, step 1 is if n is on the line, then you can say that this is the most crucial step. ON is equals to the equation on the line. Put it out in one bracket. Find out. Okay, so look at the diagram. Pn is perpendicular to the line. Find out what is Pn. Step 2, in terms of lambda. Step 3, Pn dot the direction vector of the line is equals to 0. Find the lambda. And then step 4, put the lambda back into your ON. Okay, so that's how you find the foot of the perpendicular, and usually accompanied with the foot of the perpendicular, right? There's going to be like 3 types of question. Okay, so I'm going to draw the line again. Okay, so the line is here, and we have this Q as well as a direction of 1 minus 2 minus 4. Okay, Q is 1 minus 1 minus, okay, so you will always have a point 1 minus 1 minus 2, and then you will have a P that's here, which is 1, 2, 3. Okay, and I already found what is n. Okay, so crucial. First part, the question asks you to find what is n, and n is equals to, okay, whatever that complicated, okay, is, that would be, okay, so let me just, for the sake of example, right, let me just assume that n is like 501. Okay, let's just assume that n is equals to 501. Yeah. So after you found this, right? Okay, question asks, what is the perpendicular distance from P to n? So all you need to do is to take the lambda. Okay. Take the lambda, sub back into the Pn that you found previously. Okay, so you see over here there's a Pn. Can you see over here in step 2 there's a Pn in terms of lambda, right? Yeah, just take the lambda, put into here, and then you're going to get a vector. After that, to find the perpendicular distance, okay, you just need to find the magnitude of Pn. Yeah. Okay, so this type of question is easier to do because you already know n already. It's not like at the start, right? Okay, if I don't know n, then I'm going to use these 3 thing, which is length of projection, projection vector, and perpendicular distance. Of course, you can also use that. You can also use that, you know, to help you find out. But if you have n already, then it's easier to just use the coordinates of n, find out Pn, and then the magnitude of Pn, and then that is the answer. Okay, the length of projection of P on the line. Okay, so the length, or rather the length of projection of QP, okay, on the line. So the length of projection, so for A, right, if you want the perpendicular distance, is find Pn. So for B, you must know that the length of projection, we are looking at this, right not? The length of projection will just be equals to Qn. So again, you find out what is the vector Qn and find out the magnitude. You can get the answer already. So when you have n, it's very easy to find a lot of things. Okay, but when you don't have n, then what you do? Use the three formulas that is over here, length of projection, projection vector, and perpendicular distance to find out. Okay, you can use either of these two methods, but when you have n, it's actually a lot easier. Okay, and thirdly, okay, the coordinate of P prime, which is a reflection. So when you see reflection, right? Okay, reflection, you must use ratio theorem. Okay, because reflection means that the ratio is cut into 1 and 1, is cut into half. Okay, so in this case, P prime is where? Qn, the line, right, is the mirror. So if P is here, then P prime is here. Okay, so P prime is here. Now, a lot of times students make this mistake is, I know that in ratio theorem, I need to draw the triangle like that, right? Yeah, you can draw the triangle like that, doesn't matter. So P is here, and then cut into half, this is N, and then this is P prime. A lot of times students use Q over here. So remember the top of the triangle of ratio theorem, right? Don't have to use Q, we can use O. Why? Because vectors is now in a 3 dimension. So O is, all these points, right, are with respect to O. The coordinates is always with respect to O. So O is like somewhere on top of them, that, you know, this 1, 2, 3, 1, negative 2, negative 4, right, yeah, are all with respect to O. So in the ratio theorem, always use O at the top of the triangle. Okay, so you know that if this is a mirror, this is 1:1, right? Yeah, and then by ratio theorem, okay, this goes to here, this goes to here. On is equals to OP plus OP prime over 2. So again, my ON is not the correct value. I just use 501 as an easy calculation. Equals to OP. OP I already have 1, 2, 3. Okay, plus OP prime. Which is what I don't know, OP prime, yeah, which is something over 2. Okay, multiply the 2 here, 2, 501 equals to 1, 2, 3 plus OP prime. Okay, and then I'm going to just minus off OP prime is going to be 10, 0, 2 minus 1, 2, 3, and I'm going to get an answer 9, negative 2, negative 1. Okay, so that's my the coordinate of the line of reflection. Okay, so sometimes the question may tell you to find may say that, the line is reflected. Okay, so again, if you want to find another Cartesian equation of the line, then the line QP prime, okay, is such that I need a point, just use Q. Okay, always have R equals to R equals to Q, 1 minus 1 minus 2 plus lambda. Now direction. Okay, so look over here, you need QP prime. So just use 9 minus 2 minus 1, or minus the 1 minus 2 minus 2, minus 1 minus 2, yeah. So basically this is P prime minus Q, yeah. Okay, just take this direction, and then you're going to get the answer 1 minus 1 minus 2 plus lambda, like 8 minus 1, 1. Okay, so that would be the vector of this line. The equation of QP prime. Okay, so this part is the most important part of vectors 2, where you must understand how to find the foot of the perpendicular. So let me just go through from the top again. If the question never asks you to find n, then you know, as long as you have 2 points, A and C. Okay, so just form the hypotenuse and then the line here, then the length of projection would be, so in this case, if let's say this guy is the line, okay, then you will have a direction, right? There will be a direction here, right? Yeah. Then the formula for length of projection would just be equals to hypotenuse. The hypotenuse is a vector, okay, dot d hat, because the d is the floor, okay. the projection vector would be the hypotenuse dot d hat times, okay, so this is no modulus, times of d hat. Okay, so the d hat is the vector that is on the floor. Okay, and then the perpendicular distance would be equals to hypotenuse cross d hat. Okay, this will give you the three things that you want. Okay, but if the question which the question you usually ask you to find the foot of the perpendicular, which is to look for n. The first step important is n lies on the line. So n will be equals to the equation of the line. Then use the ON, right, to find Pn. Why? Because look at the diagram. Pn is perpendicular to the line. You find Pn in terms of lambda, you dot the direction equals to 0. No need to dot the hat, just dot the direction equals to 0 can already, because two vectors are perpendicular. Okay, find the lambda, substitute back to ON, you can find ON. And afterwards, if the question asks you to find the perpendicular distance, you see what the question wants in terms of a vector, find the vector, and then take the magnitude. Either you, Pn or Qn, okay? And when the question wants you to do reflection, okay, use ratio theorem, and on top of the ratio theorem, the triangle, always use O, okay, to find the coordinate on the other side, okay? And if the question wants you to, again, find out what is the equation on a line is always a point plus lambda times of a direction. How to get a direction? The difference of 2 points will always give you a direction.